I kept referring back to like the way that I learned all
Yeah.
that.
I was afraid she's gonna make us do like square root one. I was like, I
Yeah.
don't want to do that.
It wasn't hard. Like I was able to get an answer, but I just don't think I did it her way. So
Yeah. All right, guys. So I just recorded the session. So we're just gonna go ahead and go over some problems. So let's see here. Which one?
Yeah, 3.2 number 2.
3.2 number 2? Okay, let me check that out real quick. All right, so we're gonna go over 3.2 number 2. Let's see if I can find it.
You want me to open up the book too?
Nope. Let's see.
You want to do everybody do it by himself first, and then we all figure out who's right?
I think
I'm gonna be wrong every time we do that.
I mean, we can work together if you want to do that. I'm fine.
Section 3.2, number 2. Okay. Yeah. All right. So yeah, we got to pull up the book here. Hold on, virtual people. We're just pulling up the problem real quick.
Okay.
Okay. So we have number 2 on the textbook is f of x equals x minus 1 squared plus 1, and we're trying to find the derivative of that function at x equals -1, x equals 0, and x equals 2. So let me go ahead and just write it over here. Wait, where's textbook at?
Huh?
Wait, where's textbook at? Oh, okay.
Oh yeah, it's back
All right.
there.
Okay. So it's all right. So we're gonna look at number 2, and this is.
Oh yeah, we did. Yeah, we already did this one.
We did number 2.
Yeah.
Yeah.
Let me check it out. That's
Yeah, I was thinking it looked familiar with the.
Oh wait, number 2. We already did number.
Yeah,
2?
we did it in class the other day.
Oh wait. Oh, we did. Do you still
Yeah.
want to do it, or do you want to just skip it?
We could skip it because I can already I can go back to it.
Okay. All right, guys. So we're gonna skip number 2 because we already covered that in class. So do you guys have any other questions for section 3.2, virtual people? Any questions on 3.2?
No.
All right.
Yeah, let's
6?
do. Yeah, let's do.
Okay, hold on. Let me see. All right, so we're gonna do section 3.2, number 6, which is
Ugh.
r of s equals square root of 2s plus 1. We're trying to find the derivative of that at s equals 0, 1, and 1/2. All right, so let me go ahead and just write that here. So it's r. Let me move this. Then okay, this is working. Okay, so we have. Oh my god. Hold on a second. Whoop. Okay, so we have r of s equals root 2s plus 1. So we got root 2s plus 1, and this is at r prime 0. So you have to find r prime at 0. It was at 1 and 1/2, right?
Yeah, 1 and 1/2.
Okay, thank you. Oh, this is so bad. Sorry, guys, it's a little bit messy, but I'm gonna try my best here. Okay. So.
Somebody else was trying to get in.
Oh yeah. Okay.
Okay.
All right. So we're gonna find the limit of this derivative. So we're gonna just use the formula that she put. So it's the limit as h approaches 0. So you take the function r of s and just put h. So wherever you see s, you just put plus h. So it's gonna be root 2 times s plus h plus 1 minus the function itself. So just f of x, or in this case r of s. So it's just gonna be 2s plus 1 all over h. So then from here, you just gotta distribute and just simplify the top a little bit. So it's gonna be limit as h approaches 0 of root 2s plus 2h plus 1 minus root 2s plus 1 all over h. All right, so then here, from this point on, you notice that you have to use conjugates because we have 2 square roots and we have to cancel this out, right? So we're just gonna multiply this by 2s plus 2h plus 1, and then we add the root 2s plus 1, and then same thing at the bottom, so root 2s plus 2h plus 1. How are you guys doing? Like here, you're good?
Yeah.
Are we good? Okay, just want to make
I'm
sure.
just trying to
I'm just like very. All right. So.
Yeah, I was gonna my bad. I was gonna say
Yeah.
for this section, like 3.1, 3.2, I'm gonna have to try to like teach myself because I've been behind, but I'm just gonna be listening until y'all go back to like 2.1.
Okay, so you want us to review 2.1 as well?
Yeah, I mean, after y'all done with this one, I thought
Okay.
you were gonna
Alright,
go
yeah.
through all of it.
All right, yeah, we'll definitely do that, OB now, right? All right, thanks for letting us know.
Thanks.
Okay, so, and then from this step, you use conjugate, so you just have to distribute, fold this out. So then this is gonna be 2s plus 2h plus 1. Oh God, sorry, let me, this is plus 1. This is a little, let me rewrite that again. Sorry about that, guys. So this is gonna be
It's minus.
2s plus 2h plus 1, and then minus the 2s, and I'm gonna go ahead and just, it's like that.
Okay.
All right.
Are those supposed to be
And
minuses
this is
there?
supposed to be minus here too, right?
Yeah,
Okay.
I think those are minuses.
Yeah, so this
back
is gonna
there.
be minus, hold on a second, guys. Let me adjust here. Minus, and then you divide, and you have h times root 2s plus 2h plus 1 plus
Wait.
root 2s plus 1. All right. So then from here, you just have to cancel it out. So you have plus 1, minus 1, and then you have the 2s minus 2s. So then we bring this down. You have the limit as h approaches 0 of 2h over h times root 2s plus 2h plus 1. Just trying to fit it all in, plus root 2s plus 1. So yeah, it's it is hard AF. Okay, sorry guys. I know this is looking a little bit messy. I'm just trying my best. I kind of know how Dr. Burke feels right now, so like when she writes on the board too. So that's why it's like she uses a pencil, so it's more like, yeah. I'm trying to. All right. Oh yeah. So then cancel out the h's, and then you just plug in 0 from here. So if you do 2 times 0, that's just gonna be 0, and then you have root 2s plus 1 plus root 2s plus 1. So that's gonna be 2 over 2. 2s plus 1 root 2. Because here you're adding the 2 roots, right? Because when you plug in 0 here, this is going to be 2 times 0, which is just 0. And then you have root 2s plus 1 plus root 2s plus 1. So that's just going to be, you just add those roots, so you get 2 root 2s plus 1. And then from here, obviously 2 divided by 2 is just 1, right? So that cancels out. And you get 1 over root 2s plus 1.
I just want to see what's
Yeah.
happening here.
Yeah.
I mean, honestly, it looks pretty good, all things considered.
All right. So all these steps helps you find the derivative of the actual function itself. So this is the function, the derivative of this function is this. Now, there's actually an easier way to do this. You can use this utilizing the differentiation rules, which is the power rule in this case, because this is a square root, so this is the same thing as saying 2s plus 1 to the 1/2. So those of you who already took calculus, you know that like you can use the power rule so that you can bring this down and then subtract the power by 1. So this is like a way to check your work. So like, hold on a second, let me, okay. So if you, it's okay. So if you use the power rule, this is the power rule. The formula is this. So if you have a function raised to a power, you can bring this down. So you have n, x, and then this is to the n minus 1. So if you use this formula to find the derivative of this function, you can definitely do that. So in this case, it would just be 1/2 times 2s plus 1. And then this 1/2 you subtract by 1. So like in the formula, we brought down the n, which was the 1/2, right? So 1/2 times 2s plus 1, and then the n minus 1. So it's going to be 1/2 minus 1. So this is going to be to the negative 1/2, right? So then this, if you readjust this, this is going to be 1 over root 2s plus 1. And you can see that this matches the same thing here. So you can see that that took like 3 seconds, right? That was much quicker than doing all this algebra, but you cannot use this. I repeat, you cannot use this in the test because she has not taught us this in class, but this is just an easier way to find the derivative of the actual function itself. So you have to use all this algebra. You have to find the derivative of the function by using the formula limit as h approaches 0, f of x plus h minus f of x over h. So that's a way to check to make sure if you got the correct answer. And now we're not done yet because we still have to find the derivative at s equals 0, s equals 1, and s equals 1/2. So we just have to, let me see, how do I get, can I add another thing here? Let me, this is 1 over, I'll add another screen here. All right, so we got, all right, so our prime of s equals 1 over root 2s plus 1, right? You can still see the screen, right, guys? Virtual? Can you guys see the screen still?
Yeah, I can
Okay,
see the
perfect.
screen.
And how are you guys doing so far? Is this good so far?
Yeah, it's going great so far.
Okay, perfect. So then we have to find the derivative at s equals 0, s equals 1, and s equals 1/2. So all you gotta do is just plug it in. So if r prime is 0, that's gonna be 1 over root 2 times 0 plus 1. So that's gonna be 1 over root, this is gonna be 0, so this is gonna be root 1, which is just 1, right? So this is just gonna be 1. There we go. And then r prime at 1, you plug that in. 2 times 1 is 2 plus 1, 3, so you get 1 over root 3. Oh, sorry, hold on a second. Let me do that again. So if you want to, usually square roots are not on the denominator, so if you wanted to adjust this, you could just multiply the numerator and denominator by the root 3, and then it'll just get root 3. Oh god, sorry guys, the mouse. Root 3 over 3. All right. So.
Do you think we have to do that on the test?
I don't think so. I think. Yeah, you could.
Yeah,
Yeah.
I mean, they're either way probably correct.
Yeah. Either way, they're correct. Yeah. I think it's not a big deal. I usually change it because, like, you know, in the unit circle, you don't like, because you don't see it like this. Like, it's usually this way. But
Yeah.
either way, it should be fine. Yeah. And then same thing. So you do r prime of 1/2. Oh, sorry guys. Oh my god, that fraction symbol. Let me do that again. So let's erase that. And then, okay, so r prime 1/2. So you do 2 times 1/2, that's 1. 1 plus 1 is 2. So you have 1 over root 2. So if you wanted to, do the same thing to rationalize the denominator, it would just be root 2 over 2. So that's what you'd have got. Is that what you guys got?
Why does this make so much sense when I'm sitting here, but in class?
Face to
I'm
face, yeah. Yeah.
It's just the face-to-face part. That
Yeah.
really just makes such a difference. Seeing something like that step by step in front of you
Yeah.
versus,
I'll show you here. So this is the work.
Yeah, like I only stayed home on Tuesday so I could use my notes on the quiz.
How'd you guys do virtually? You guys doing good?
Yes, I'm doing good.
Do you guys have any questions?
If that's
No, it makes more sense because in class I was so confused.
Yeah.
Huh?
It's not the thing is with this content, it might look hard, but it's actually just the algebra. It's just very tedious. You just
Smarter,
have to make sure
not
you keep
harder.
track of everything.
Like,
So
I was gonna fail.
but yeah, like I said again, do
So
not
I
use
just- I just
this
stayed home.
with the differentiation. I was just showing you like the easier way of calculating the derivative of this function. So you have to make sure that you use this, like the whole thing that she taught us today. So yeah.
Well, that's not the limit formula.
Sorry, Albina, what'd you say?
Was that the limit formula?
Yeah, so let me go ahead and write the limit formula again. So it's let me add it real quick. So it's the limit as h approaches 0.
If you need to,
It is.
think I have
Oh
it
god,
written down
I'm
if you
so
wanna
sorry. Hold on, let me
see
erase this real quick because I'm writing with the mouse, so it's a little hard. Hold on. So it's f of x plus h minus f of x all over h. So this is the
like, I
formula that
hate
you have to
taking, like,
use
6 pages of
to find the
notes every day
derivative
'cause,
of
like,
the function itself,
so
or to
quick.
find the derivative of function at a point.
I write too
All
much
right.
and I get mad
Does
at
that make
myself
sense,
for
Abina?
wasting all the
Yeah, it does.
All right, cool.
Exactly. And
Do
then
you
I
guys,
start a new page because I can't fit a whole one.
Do you guys want to do a problem where you have to find the derivative of a function at a point? So this example was just to find the derivative of the function itself, and then you just plug in the points.
Yeah, can we do one
So,
of those?
okay, yeah, so to find the derivative function at the point is the same process. It's just that you don't have to find the derivative of the function itself. You just have to put like h plus whatever your x value is into the formula. So we can do a problem. Which one do you guys want to do? Which one?
Probably one of the easier ones. Or these, I honestly don't remember which numbers we did.
Yeah. Let me see. I can go ahead and I'll pick a problem and we can find the derivative of a function at a point. Let's see. Like a straightforward one, I guess. Let's see. Let's do maybe this one. Okay, so we have. Let's do find the function f of x equals 5x. This isn't a homework problem, so I'll just do this again. So you have 5x minus 3x squared at x equals 1. So to find the
Huh?
derivative of a function at a point.
I think she just pulled it out of the homework or
Oh yeah, I just
something.
pulled it. Hold on, I'll tell
I'll
you.
write
It's
it.
number 19.
5x
And
minus 3x squared.
Hold on a
x
second.
equals 1.
Hold on, guys. Let me erase this real quick. I want to tell you which one it is. So this is section. This is section 3.1. Oh my God. Sorry for the handwriting, guys. Like, okay, section 3.1, number 19. I'm picking an easier problem just so that I show you guys how to find the derivative function at a point, because we definitely have to cover a lot more stuff, so I don't want to waste time. Okay, so minus 3x squared at x equals 1. Okay, so you basically use the same thing. So limit as h approaches 0. So f of x plus h. So this is, hold on. Let me.
Did you do it twice?
So in this case, you don't have to find the derivative of a function using the, hold on. You have to use this, but this is to find it from the function itself. So you see how we got like a function using the limit formula? To find it at a point, you should get like a number as your answer. So to do that, like she said before, she used like x naught, f of x naught plus h, right? And then like f of x naught, right? So we know that x naught is 1, right? So if we do f of x naught plus h, right, that's going to be this. So this function plus h. So it's just going to be, just 1 plus h. So it's going to, hold on a second. Let me, I need to get my eraser. Hold on a second. Let me, so.
I think he's trying
Oh,
to
okay,
see.
okay. Okay. All right. So this is going to be f of 1 plus h, right? Yeah. Exactly. So then, yeah. So then if we do f of x naught, right? This is, hold on a second. You just need these two. All right. So you do f of 1 plus h. So every time you see x naught, this will just be 5 times 1 plus h minus 3 times 1 plus h squared. You have any questions, Obina? Or because I think the microphone is like
Oh yeah,
echo.
yeah.
Yeah, there's like an echo.
Hold on, there's a little echo, and then this is gonna be all over h. So it's f of x naught plus h minus f of x.
So you can stay here.
F of x naught plus h minus f of x.
Yeah, that's
For x, why would you put in 1 plus h instead of just 1?
So in this case, so remember the formula is f of x plus h minus f of x, right? So
Yep.
in this case, since x is 1, you just have to replace the x with the 1, right? So we just put in the 1 plus h. Every time we see an x, we have to put h plus something. So in this case, we're given x, right? So x equals 1 equals 1 plus h, 1 plus h.
Oh, okay, yeah.
Yeah, plus h, and then minus the function itself. But you have to put in the 1 because we're basically doing f of 1 plus h minus f of 1 over h, if that makes sense. So this is like, well, this is to find the derivative at a point.
Yeah, so that's like the base formula, basically.
Yeah. So this is how to find the derivative of a point. You just have to put in the x value. The last one we did, you just have to find the derivative of the function. So that's why we didn't have a number or anything like that. We just, whatever variable we found, we just put the plus h next to that. So, but since we're finding at a point, then we have to put some x value into the formula. Does that kind of make sense?
Yeah,
Yeah,
that
that
makes
makes
sense.
sense.
Okay, so then let me erase this so that I can have more space to do the work. And then how are you guys doing? So I'm doing it all virtual because like most people are gonna watch the recording. So okay. So okay. So then we do minus f of 1, right? So if we plug in 1, this is gonna be 5 minus 3, which is just gonna be 2. So okay. Well, hold on. This is gonna be minus 2, right? So then you just gotta simplify the top. So we got limit as h. Oh God, sorry guys, the mouse is annoying. Okay, so this is gonna be 5 plus 5h minus, and you just gotta simplify this. This is h plus 1 squared is h squared plus 2h plus 1 I feel like you can do this mentally, or I mean, if you can't, then you just do it on the side, be like, what's h plus 1 times h plus 1, and then just go from there. So that's going to be plus 2h plus 1, right? So you do minus 3 and then times this, right? So to simplify, because that's what we did to simplify there. So that plus 2h plus 1 minus 2, right? All over h. So then we just simplify this. So this is going to be, all right, so I could have skipped a step there, but like, you know, that's fine. So we get 5 plus 5h minus, so just distribute. So you get 3h squared minus 6h minus 3 minus 2 over h. All right. So then
is the minus 2 coming from like where you solved?
yeah.
That?
The minus f of 1. Ooh. Yeah. Okay. So then once
so instead of writing all this out, you just went ahead and
all right.
solved for it.
So then now you just simplify. So what's 5
So
minus
you do
3? That's
like
2. 2 minus 2 is 0, right? So that's just going to
5
cancel out, right?
1
So you have limit as
minus 3 times
h.
1
Oh god,
squared
my mouse. Okay, h approaches 0.
2.
This is going to
So you
be
just went ahead and solved for it.
5h minus 3h squared minus 6h all over h, right? You just got to make sure you follow along and just make sure you're simplifying everything throughout the process, right? Okay, so I don't want to, I can try to maybe put space here. All right. So then you got to factor out an h in the numerator, right? So again, we have to do limit as h approaches 0. You factor out an h, and you'll get 5 minus 3h minus 6 divided by h. So that's going to cancel, right? So you have limit.
Divided by 8. Oh, you factored that.
Yeah. As approaches 0. 5 minus 3h minus 6. And then you plug in the 0. That's just going to be 0.
So you have negative 1.
And then you should get negative 1. Yeah. Oh, God.
Minus 3h squared minus 6.
Yeah.
Oh, no, we already got rid of that.
So that should be negative 1. And then if you wanted to check if you were correct, you could just take the differentiation rule, so f prime x, and this will be 5 minus 6x. So if you do 5 minus 6x and you plug in 1 here, it'll be 5 minus 6, which is negative 1, which is correct. I was just doing that mental if you wanted to like check with differentiation rule, but if you already took calculus, then you could do that too. So, but I just checked the work, so this is the correct answer.
Two
How's
things.
everyone doing virtually? Are we good?
Yeah. I understand how you got the answer. About that differential rule, how you check it, how would that work again?
Okay, so the differentiation. Okay, so there's so that's what you use the differentiation rule like with powers. So I'll give you an example here. So like let's say you have. Actually, let me put the formula here. Hold on a second. How are you guys doing here in the table?
The final answer was
are we
negative
good?
1, right?
Negative 1, yeah.
It's the slope, and then if you had to find the equation, you could either do this.
Oh yeah,
point
and
slope,
yeah, the point slope
but
form.
I like the y equals mx plus b.
Yeah. All right, so yeah, I'll give you an example. Hold on a second. So if we have like, for example, if you have a function raised to a power, right?
Yeah.
So let's say f of x equals this. To find the derivative, you just have to take the n, put it down, and then you do x to the n minus 1. So for instance, if you had like, let's say, like 6x squared, like a simple function, to find the derivative, you just take the 2 down. But remember, since these are being multiplied, you're going to have 6 times 2, right? X, and then this is going to be 2 minus 1, right? So that's 1. So the derivative of this function is 12x, right? So here, if we go back, if you wanted to check your work for this, we can use the power rule for this. So if you do f prime x, like the same thing, right? 5x, this is raised to the first power. So if you bring this down, 5 times 1 is 5, so that's just going to be 5.
I think.
X, and then raised to the first power.
Is that what you got?
So if you notice, this is the raised to the first power, so 1 minus 1 is 0. So this, x to the 0 is just 1, right? So this is just going to be 5. And if you take the derivative of this piece, same thing, you bring the 2 down, so you get negative 6, right? Because 3 times 2 is 6. Then you have x, and then we have 2 minus 1, that's going to be to the first power. So if you plugged in 1, right? So you have f prime 1, you have 5 minus 6 times 1, we get
Okay, so just making sure.
we get negative 1, which is what we got here. You see that?
Yeah.
Does that kind of make sense? But this is just for, but you have to be careful because this is for power rule. This is for a function where you have a power. So if you have something like this, like if you have a like x plus 6 over 2x squared minus 3, you cannot use a power rule for this because this is quotient. This is quotient rule. So she's gonna teach all this to you guys next week. I don't want to go over this now because she said that you can't use any of this in the test. So you have to use this to find all your derivatives for now. But for the next test, you could probably use it. So yeah.
One last thing. Where did that -2 come from on the last problem?
Which one? Sorry, I have to raise the volume. What'd you say?
My fault. I said, where did that -2 on that last problem come from the very beginning?
From the very beginning. Which one?
Complicated ones, only the single
Here?
complicated ones.
This one, yeah, the -2.
The negative. Okay, so this came from
one for the team and just
f of 1. So you remember how I said that it's f of x plus h minus f of x. So since we're trying to find it at a point, right? We said this was 1, so this is f of 1. So if you want to find f of 1, you have to plug in 1 to this and this. So you have 5 times 1, 5 minus 3 times 1 squared. So 5 minus 3, that's 2. That's how we got that part. Does that make sense?
Yeah. Okay.
Okay. All right. So you have to also know how to find this using. You have to use point slope form for this. So remember, point slope form is y minus y1 equals m times x minus x1. So if we go back to the problem, we have to write this in point slope form. So we know the slope is -1, right? So the slope is -1, and the point was at x equals 1, right? We just need to find what y is. So to do that, we just have to plug in 1 to the function, right? So this is going to be 5 times 1 minus 3 times 1 squared. So that's the 2. So we know y equals 2. So then you just got to plug this into the thing here. So we have y minus y1, which is 2, equals m, which is -1, times x minus x1, which is 1. So that's point slope form. You could leave it there, or you could convert it to slope intercept form. So this will be -x plus 1, and then you have y equals -x plus 2 plus 3. So this is what you should get for the in slope intercept form, and this is in point slope form. So yeah,
Wait, you have
-x plus 3. Is that what you got?
No. I got.
Is that what you got? Because you got -1, and then hold on. Or I'm just checking with Bree'Anna to make sure this is correct.
Was the y not a -2?
No, because isn't it 5 minus 3, right? So if you plug in 1, so that's positive 2.
Oh.
So that's why it's -2. This is y minus y1, so this just stays as positive 2. Does that make sense?
I just did it with -2.
Okay.
So
All right. Do you guys have any questions? How are you guys doing?
Good so far, no questions.
Okay, cool. All right. I'm so sorry. I feel like I'm not paying attention to you guys because this is gonna be recorded. So all right. What other problems?
It's -x.
Oh, okay,
plus
cool.
3.
Which one do you guys want to go over next? Like intermediate valid theorem, continuity. What do you guys want to do next? Limits at infinity. DMZ. Which one do you guys want to go over? Every set. Okay.
Right.
Yeah, I also say like maybe review over every section, maybe.
Yeah. Okay. All right. So let's see. So we already gone over derivative, the function derivative at a point. So maybe we could do
Something from 2.7, was that the last?
Was that 2.7? Let me see. 2.
We didn't?
2.5 and 2.6. 2.5 is continuity. 2.6
Yeah, you're right. So
2.5 and 2.6. Okay, hold on a second, guys. Let me
2.6.
pull it up here real quick. 2. Okay, yeah. We're gonna start by doing limits involving infinity and infinite limits. So let me just pull up a problem here. Okay.
I feel like the questions are going to come from the first section, like one of the first couple sections, because that's where she gives us the
Let's
most
do this one.
from. I don't know if that's a stupid assumption, but that's what I'm banking on.
Section
We
2.6.
haven't looked 3 weeks out of 4 weeks. Chapter 2, so.
Like the random number 31 she gives us, it's going to be that one every time. I would die because I never get that far.
All right, so we'll do section 2.6, number 14, which is f of x equals 2x cubed plus 7, all divided by x cubed minus x squared, x cubed minus x squared, plus x plus 7. Okay, so we have to find we have to find the limit of each rational function as x approaches infinity and as x approaches negative infinity, all right? So this is with horizontal asymptotes, right? Because whenever a function is approaching infinity, rational functions look like this, right? So we have this, right? So as it's approaching infinity, it's gonna approach some number, right? So if we, like she said before, when you're taking limits at infinity, you have to basically just divide by the highest power in the denominator. So in this case, the highest power is 3, right? Or you could also do, if you know rational functions really well, there's like a really tricky, a good trick to use. So if you if you notice this, we have the same power here. So the highest power in the numerator is 3 and the highest power is 3 here. So they're both the same. So when you notice that, you can just take the ratio of the leading coefficients. So in this case, it's 2 and 1. So the answer is literally 2. I mean, I can still show you using the algebra too, but like you could also use that as well. And all right, yeah.
So are we allowed to do that?
No, I think guys, I think you have to make sure you show your work. You could use it, but yeah, I think you guys have to use algebra.
Yeah, that's
Yeah,
what I'm like. If it was on, I mean, I haven't watched any of those, but
exactly. Yeah. Yeah.
But she's like, yeah, you can't take the shortcut that this
L'Hopital's rule. Yeah, exactly.
like I'm used to math teachers being like, okay,
Yeah,
here's
so
the
it's
hard
just
way,
gonna
here's the
be,
easy way. Use whichever one works for you. I'm
so
not used to like you're gonna learn it the hard way, and then later, like you can do it the easy way.
We're just doing it with limits now instead of actually doing
all right, so basically, like, this is an example. So, like, if you have the same power, then you just do a over b. So in this case, it's 2 over 1, right? Oh, God, sorry, guys. What the hell? Okay. Or if you have, okay, so another thing is if the power on the top is less than the power on the bottom. So let's say this is, hold on, let me just make up a variable here. Hold on a second. Let's say this is C. Let's say N is less than C, right? If this power is less than this, usually it's gonna be 0. So like the horizontal asymptote is gonna be at 0. So the answer is typically gonna be 0. But if it's like this, if n is greater than c, it's gonna be some number. So you're probably gonna have to do the algebra. So like you can look up the rules for this online, but like this can give you just a general idea on how to work these problems a little faster. Because this is a time test. So how does she? How long is it the test again?
An hour.
Oh,
and
2
40
hours.
minutes, I guess.
Or an hour and 40 minutes. Okay, yeah. So just like a general rule of thumb, you could use that as well.
Wait, how many questions gonna be there?
25.
Wait, 10?
10?
I thought it was
Or
10.
10. I lied.
Oh, okay.
Like if it's multiple choice, maybe I can swing it.
45, guys. You're gonna
Bro,
suck.
please, if it's multiple choice, I got it.
I'm gonna have a quick right out the gate.
No, it's okay. It's gonna be 10 questions. She said that some people can finish quicker, so like in 25 minutes. But she said to not worry about it, because you guys can use all your time. So it's
Yeah.
important that you do check your work because, like I said, these problems definitely can be a lot. So it's important that you do take your time because you might mess up on like a sign or something like that. But like, yeah, definitely use all the time. So. All right, so we already know this answer is going to be 2, but I'm just going to show you the algebra. So you have 2x cubed plus 7 over x cubed. What? No, yeah, I'm good, yeah. So I'm going to multiply this by, so since the highest power in the denominator is 3, we're just going to multiply this by 1 over x cubed, right?
Hold on.
So limit as x approaches
Is that
infinity.
just the rule?
Yeah, she said that like if you take infinite limits, you can just multiply by the largest denominator, like the largest power in the denominator is 3, so you just got to divide by x cubed on both the numerator and denominator. So once you do that, then you just have to like multiply this out. You can do this mentally, like if you do 2x cubed times this, that's just going to be 2, and then this is going to be plus 7 over x cubed, right? Because 7 divided by x cubed, and then you have x cubed divided by x cubed, that's just 1, and then you have negative x cubed divided by x cubed, that's just going to be negative 1 over x, right? Then you have x over x cubed, that's just going to be plus 1 over x squared, right? And then you have plus 7 over x cubed. So when you plug in infinity, I mean, it's not really proper to plug in infinity, but like if you do, this is just going to be 0. This is going to be 0, and that's going to be 0, and that's going to be 0, right? So then now you notice 2 divided by 1, that's 2. That's what we got in the beginning, right? So that's
zero,
that.
Blah blah blah.
That's the answer.
Equals 2.
Yeah.
Okay.
All right. How you guys feeling? Virtual.
That's good.
Good, yeah.
Okay, cool. All right. Let's do. So
do you only need to do limit as approaches infinity and not negative infinity?
we can also do negative. Oh yeah, let's do this function at negative infinity. So if we do the same thing, so at number 14, so it was fx equals 2x cubed plus 7 over x cubed minus x squared plus x plus 7, right? So, and we want to find the limit as x approaches negative infinity. So same thing. We just do the same. Okay, hold on. Hold on a second. Let me do it. Right here. 7 cubed minus x squared plus x plus 7. So same thing. 1 over x cubed, 1 over x cubed. Just the same thing that we were doing earlier. I really didn't have to repeat all this, but so you have 2 plus 7 over x cubed over 1 minus 1 over x plus 1 over x squared plus 7 over x cubed. So if we plug in negative infinity, then this is just going to be, it's the same thing. So 7 divided by a really, really, really small negative number, that's just going to be a negative 0, I guess. And this is just going to be 1 over negative infinity. So that's, it's literally just going to be all 0 again. I really didn't have to do all that again, but that's still going to be 2,
So
even with the
limit
negative
exists
infinity.
because they're the same from both ways. Is
Yeah,
that-
so that's it's the same from both ways, so you still get 2.
If
Alright.
they're different from both ways, then it's not.
It does, so I really want to look at a problem that's like that. Sometimes it can be different. You have to be careful just to make sure, guys, like whenever you take infinity to a even power, like positive infinity, you're always gonna get positive infinity. If you take negative infinity to actually I lied. Hold on, that's not good. Let me forget. So anything, any number to an even power, you're always gonna get. Oh my God, here, guys. It's gonna always be positive. Any number to odd power, always gonna be negative. So like if you have infinity to like 2, that's gonna be positive infinity. Like negative infinity cubed, that's gonna be negative infinity, right? So you have to be careful. Make sure that you do keep this in mind, right? Because this can come in handy when you do limits at infinity. All right. Okay. How are we guys doing? Right? Any questions? Are you good?
It's making sense.
Okay. Let's do. Let me see here. Yeah. We want to do like a.
How about I think it's called infinite limits, like as it lists, for example, like
Yeah, like
as
when you
x
get,
is a,
yeah, like when you get infinity as your answer, like that, like kind of like these here.
yeah, it's like as x is approaching -8 from the
Yeah.
positive side.
Yeah. We'll do that. I was thinking of doing one with Trig, but I'm pretty sure she's not going to test you on that. I mean, maybe, but I don't know.
I think it's safe to if we try trig, because every time I see those as a question, I don't even know.
Yeah, because this is anything with trig, you have to make sure that you utilize a unit circle. That definitely helps a lot. And if you don't remember something about the unit circle, what I recommend is just memorizing a quarter of it, and then everything is just negative, positive here. So you just got to switch the signs, like if you forgot. But yeah, that's how you do that. All right, so let's do one that's
Yeah, I haven't seen it in like 7 years.
let's do.
Yeah, I graduated college once already.
You guys want to do number 44? Section number 44, what do you think? Or do you want to do one that's like from the left, right, maybe?
Whichever you think is best. I'm not picky. I just
okay.
want to learn.
All right, let's do maybe one that's let's do like a right left hand limit and one that's just like a without a right left hand limit maybe. Okay. All right. Let's do. Okay. This is section 2. I gotta make sure I write the sections and all that. Okay. So wait, this is section 2.6. 44. Okay. So we got the limit as x approaches 0, negative 1 over x times, what was it? X squared, sorry, x squared times x plus 1. Okay, so you always have to make sure that you plug in. So if you plug in 0, you get, so limit x approaches 0, you're going to get negative 1 over 0 times anything is 0, so this is just going to be 0. And this divided by 0, that's just going to give you infinity. So let me check in the calculator real quick. This is negative over a positive, so I'm not sure if it's supposed to be negative. Is it supposed to be negative?
I think so.
Yeah, I think it is.
Isn't there like another process where you like because it's undefined, you gotta do something else?
Small negative.
Hold on a second. I'm just checking to make sure this is right. Hold on. Yeah. So this can be undefined. She typically doesn't. You don't really have to write does not exist because this is like infinity. So it's considered. So,
Yeah, because of my
yeah, yeah,
do it.
yeah, yeah.
Wait, so this is the answer?
I'm really
So it can be undefined. But let me check. I'm just checking to see here. My calculator. Hold on a sec. X squared times x plus 1. Okay. Finally, it wasn't graphing earlier. Okay. Yeah. So I've graphed it on. I mean, I can't really show you, but if you graph this function on your calculator, if you look at 0 as x is approaching 0, it's going to positive and negative infinity. So it's technically undefined. Yeah.
All right.
Yeah. Okay. So let's do one like with the right left hand limit kind of deal. So let's see. Okay, so let's look at 45AB. Again, this is section 2.6, 45A and 45B. So 45A is limit as x approaches 0 from the right of 2/3 up to the 1/3. And this one is limit as x approaches 0 from the left of 2/3 x to the 1/3. Okay, so plug in 0. So both of these are going to be infinity, but you have to be careful because this is coming from the right, right? So if it's coming from the right, if you were to plug this in, in the calculator, just want to make sure this is correct. Let's see. So we have 2/3 x to the 1/3. All right, so this is coming from the right, so this is going to go positive infinity. This is going to be infinity. Yeah, I graphed it, and then also I think you can also plug in numbers from the right. So like 0 from the right. So that's going to be like 0.001, 0.0 whatever. So this is going to be, so I'll show you here. So this is 45A. So we have the limit at x approaches 0 from the right. So like let's say you want to plug in. So if you think about the number line, right? So anything to the right of 0 that's like 0.01 or like 0.001, whatever. You know what I mean? Or sorry, 0.001, 0.01, whatever it might be. So if you're to do that, if you were to plug this in here, like 0.01, let's say, to the 1/3, you get 2 over some positive number. So that's why, like infinity. So as it gets closer and closer and closer to 0, it's going to be positive infinity. So if you can also experiment. So when you're plugging in like 0.01, go ahead and do that. Let me put the calculator 2 times 3 times 0.01 the 1/3. So what's 1/3? So if you plug this in, if you plug in zeros closer and closer, you'll get closer and closer to 0 from the right hand side. So that's gonna be positivity. But if you plug numbers from the left hand side, right? Like negative 0.01. If you plug negative 0.01, then you're gonna get 2 over some type, like some negative number close to 0. So that's why it's gonna go to negative infinity. All right.
Yeah.
Feeling good?
So how would we show that like on the test? Would we just like try it out or whatever?
Yeah, I would.
Oh, because like she said, you could do that like write very small positive.
You're right,
number,
very small positive. Yeah.
Oh, okay, sorry.
Yeah, so you could do that too. Yeah, so she was explaining that in class earlier. Like if you put like a small positive number, you could like write it out and just like put it in there and just imagine it and be like, oh, it's going to infinity, and then just like go from there. So same thing with this.
Like she'll count if she sees.
Yeah.
Okay. Yeah,
Yeah.
So like that one will automatically.
I mean, you could also graph it too. Like you could
Yeah.
just make a little graph here and be like, plug in some numbers, you'll get some function.
I'm gonna literally
So-
just show anything I know how to
So
do.
you'll just
And-
so the function looks like this.
Credit somewhere.
So if you were to graph some points and like graph it real quick and be like, oh, I noticed that as it's approaching 0 from the right, it's going to positive infinity. As it goes to negative from the left side, it's going to negative infinity, right? So that's how you can tell as well. If you want to just draw a quick graph or do this method, this is easier with the number line. Just plug in some numbers and just figure out from there. So yeah.
But overall,
Yeah. Yeah. Or undefined. Well, yeah.
undefined.
Kind of.
Whatever.
Yeah.
Whatever
Infinity.
counts.
Yeah. Sure. Okay.
Okay.
What are we doing? Do you want to do another one like left hand limit thing or?
I think that. I mean, to me, those make sense.
Yeah.
Now.
You're good? Okay. Let's do, what was it? 2.6 and then 2.5?
2.5.
You want to go?
2.5.
Sure. Okay. What time is it? Cool. Okay.
Can you do number 25?
2.5, 25. Got you. Okay. Let me scroll down here. How are you doing, Maggie? Are you doing good?
Yeah, I'm doing good.
Okay. I just want to make
I'm
sure.
telling you, this is way better than class because I'd be so confused.
Me too.
Yeah. I mean, she's a great teacher. It's just that she has to cover so much and like, you know,
Yeah.
what's going on, you know? So, yeah. But I'm very happy that you guys are communicating a lot virtually in the group chat because, you know, it's really important to like work as a team and, you know, just asking questions, you know? So that's really important, especially these times, you know, in quarantine. So like, it's
I
very
have
important.
to like mute it at night because it's like y'all are like up at like midnight. So like I wake up and there's like a bunch and I just mute it for 8 hours.
All right. So do you guys want to do, let's see. So continuity. So let's do,
We're doing number 25.
oh yeah, 25. Sorry. I forgot about that, Albina. I'm sorry. Okay, 25. All right. So we got y equals root x plus 3. What do we gotta do? Oh, okay. So we have to find.
wait,
We have to
is
determine.
That's 11 and 12, right?
Oh yeah, this
It's,
like
yeah, it's
oh,
down
oh,
there. There we go.
Yeah.
Y equals
Yeah, y equals 2. All right. So with this one, with squared functions look like this, right? Oh god, look like this. This is the parent function, square root of x. That looks like this. So if you were to like imagine this, like this is basically just like some transformations that you have to do. But basically with these squared functions, to find, I would first try to find the domain. So that would help you determine like where, because the thing is the domain of the square root of x, that's from 0 to positive infinity, right? That's the domain. So if you want to find the point of, so basically anything from the left of 0, that's going to be undefined for square root of x. So it's, but any polynomial function is going to be continuous. So a squared function is considered to be continuous. So just by looking at 25, it's already continuous. There's just some restrictions with the domain, but there's really not any discontinuities, right? So,
So
Don't you got like set to 0? Oh, my bad.
but
no,
like,
yeah, go ahead.
is this what you could look at like below, like
Oh, so yeah, so if you wanted to find like
See, I tried to do that on the quiz.
so you
and
do
she
y
gave me a
equals root
67 because that's
2x
all I
plus
knew how to
3.
do.
So you
I
take
didn't know how to do
root
it like
2x plus 3
algebra
set equal to
so, like,
0.
I knew.
And then just do the algebra. So this is square, square, you cancel that, you get 2x plus 3 equals 0.
So I just want to know.
2x equals negative 3, x equals negative 3 halves. So basically what this is trying to tell you is that at x equals negative 3 halves, so anything greater than negative 3 halves, that will be defined. So anything less than negative 3 halves, this will be square root of a negative number, which is undefined. So that doesn't work that way. So like you could experiment with yourself. So if you put like negative 2, for instance, wait, is negative 2 greater than negative 10, greater than negative 1.5? Yeah, okay. So if you plug in negative 2, sorry, I'm just making sure. So 2 times negative 2, that's negative 4 plus 3, negative 1. Square root of negative 1, that doesn't exist, right? So it's irrational, sorry, it's irrational. So basically negative 3 halves, so anything from negative 3 halves to positive infinity, that's like your domain, I guess.
Wait, it can be on negative 3/2 or has to be greater than negative 3/2.
So yeah, it has to be greater than this, because if you plug in negative 3 halves here, you're gonna get negative 3 plus 2, which is 0. So this bracket tells you that it counts, that this counts. This like if I wrote it as negative 3 halves with the parentheses, that tells me that that's telling you that this doesn't count. But this number does count, because if you plug it into x, this will be negative 3 plus 3, which is 0, and you can take the square root of 0. But you cannot take any square root, anything that's less than negative 3 halves, because like we did before, if you plug in negative 2, that's going to be root negative 1, which is irrational, so that's not going to work out. So yeah,
Okay, so that's how you could show it.
yeah, that's how you could show it. Yeah,
'Cause
for square root function
Calculator doesn't count.
particular. Yeah. Yeah, does that make sense?
Yeah.
Yeah.
Yeah, it makes sense.
Okay. All right, you guys want to look at continuity problems? Like we could go over one real quick. Let's do, I guess, 5 through 10 on this textbook. Can you guys see, you guys can see the textbook, right? Oh, you
Yeah, I
guys,
have it.
oh crap. I gotta write. How do I share? Can I share the textbook?
I don't think you can share both at the same time.
Oh.
Like, you can't share the screen and the textbook.
Oh, I'm not good at drawing these things. This will take forever. Okay, I'm gonna try my best. Should I try to draw this out and do a problem with it? Or should I just share it? I could check out like the whiteboard. Will it delete the whiteboard? No, it won't.
I have no idea.
What if I? Okay, hold on, guys. I'm
Wait,
just like.
can you like do a thing where you could like write on?
Oh wait. Can you? Oh wait. Can I? Hold on a second. Wait. Oh yes. Can you guys see it now? Right?
Yeah.
Yeah, I can see it.
Oh, the textbook. Okay, perfect. So
Admit him.
okay. All right. So now we're gonna look at 2.5 with continuity. So let's look at number. Let's see. Let's look at.
Right.
You guys want to do 5 through 10 again, or are you guys good with continuity?
Fine.
I
Are
think
you
it
guys
makes sense
Yeah.
now.
Yeah.
Yeah.
Yeah. You guys.
Maybe it makes
Yeah.
Justification for this, like when you're answering, like
Yeah.
for that question.
Hey Julio, what's up? How you doing?
Like I can just say
Oh,
yes, it exists. How do you?
yeah. Oh, I thought
Usually, if it's yes, then you think, but if it's no, then you do. Right? Because I think that's what it was like in the textbook, like when you were looking at the answers. Once it was yes, it was
Oh,
yes.
you know what we should do? Maybe we should do a continuity problem with piecewise functions. Should we do that?
Oh yeah, 'cause she said that's gonna. Yeah.
Yeah. Okay. So we're just gonna go over the continuity rules real quick. So the first, like she went over this in class already, but just to recap. So if you take the limit as x approaches c from the right of f of x, so the right and the left hand limits have to equal each other, right? So this is what it's supposed to be. And then the second rule is that the limit as x approaches c of f of x, this has to exist. So like the function itself has to exist. And then the third one is that the defined function and the right left hand limits, all this has to equal each other. So you have the limit as x approaches c of f of x, that has to equal f of c. So that's just like the rules, just, you know, so right, left-hand limit have to equal each other. The actual function has to exist, and then these two have to equal each other there. So, all right.
So wait, what's the third rule saying?
So the third rule is saying that like this and this has to equal each other. Like the
Oh,
yeah. So the right left hand limit. So like you get some number and like the function itself. So like f of 1 is 2. So like that number. So those two numbers have to equal each other.
So what is that in the parentheses? Is it f of
F of C.
F of C.
Sorry, I'm trying my best to write neat here, but neat question quotation mark.
Okay,
All right. So let's do a
that makes sense.
continuity problem with. Is that Jose? Jose, what's up, Jose? How are you? Olas? Maybe? Okay. Yeah, it's okay. Don't worry. Of course I am. Yeah. Okay. Yeah. Oh, yeah. We're watching Coco Olas for Organization Latin American Students. We have an event October. So if you guys want to watch it, I'll send you the information later today. But if you want to, yeah, it's gonna be at the campus green, so it's gonna be great. Yeah, virtual people, if you want to watch Coco, it's an event for OLAS, Organization of Latin American Students. Want to check that out? I'll send you guys the information. So, but yeah, so yeah. All right, so let's look at how to find the. All right, this is a good one. Let's do. Have you guys done 29, 20, 30? You guys want to do 30?
Whatever one makes you happy makes me happy.
Okay.
I'm just happy to see it all.
Okay, so if we let's do section. And how are you guys doing virtually? Do you guys have any questions so far? Like.
Is 2.1 even gonna be on the test, or is that something? Because I think we kind of skipped that.
That's just
I think that was just practice.
yeah. It's like the test is gonna start on 2.4, right?
Yeah,
Or
yeah,
2.2.
yeah. 2.1 was just trying to help you get the idea of how to find like rate of change and all that. That was to help you like kind of get started with limits. So I don't think that's gonna be on the test. It's more like 2.2, 2.4, 2.5, 2.6, and I believe 3.1 and 3.2. Yeah. Okay.
Was that
Yeah.
It's if you scroll up in the chat, it's like all my notes. Like I posted the notes like that she
Oh,
posted
yeah.
from the test today, and I put the sections that it's gonna be over on the top.
Yeah,
All right, I'll look for that.
which was great.
I
Like,
can resend it if you can't find it.
yeah.
All right, thank you.
Also, it's in the recording. She puts the recording in the Blackboard, so if you miss any like important content or anything, you can just go back and check it out. So, yeah.
Yeah, like for me, like my main concern is like because I have to teach myself like because of Khan Academy and all that stuff.
Yeah, the thing is, okay, so I took AP Calc in high school, and I took the exam, but when we went all virtual, I was kind of done at that point. I could have just taken the opportunity and got a 5 on the exam because there's no web camera, there's no lockdown browser. Let's be honest, everyone cheated on the AP exams this year. Like last year, come on, like, I don't know, but yeah, so, yeah. Yeah, but I'm majoring in engineering, so I kind of want to take my time with calc either way. So I mean, it's fine. Like,
yeah. Besides, I should not have gotten 5 I definitely got one of the questions wrong.
oh my god,
They just curved it too heavy. 'Cause so
I know.
Yeah, I mean,
All right, so we're gonna do number 30,
'cause they count
section 2.5. Okay, so that's gonna be f of x equals x cubed minus. Okay, so we got x cubed minus 8 over x squared minus 4, and then that's 3. Oh god. Okay. So x cannot equal 2, and then oh my god. Sorry guys, my cannot equal -2, and then x can hold on a second. Am I writing this right? Yeah. X equals 2. I don't know, cause like, I did like homeschooling middle school, like for tennis and all that. So I used a lot of whiteboard on the mouse. I haven't used it in a while, but like I'm just trying here. So, I don't know. Yeah. Okay. Just slowly.
nothing to take is definitely.
So for this, first of all, what's the question? Okay. The question is asking, at what points are the functions in exercise 13 to 32 continuous? Okay. So. All right.
Is this one 3 like
X does not equal -2 for that
Oh
function.
yeah. Okay.
Yeah. Okay. So for this one, what I would do is we'll typically find the right. So we're talking about continuity here, right? So first things first is to find the right and left hand limits and to find where the function is defined. So in this case, if we plug in f of 3, right, that's going to be 2, right? Because x is here, and then we have x 3, we get.
Wait, wouldn't it be the other way around?
Yeah. Thank you for correcting. Hold on a second. Yeah, so it's f of 2, right? So f of 2, and you get 3, right? So that's the first one. So the right and left hand limit have to equal 3 in order for this to be continuous. Okay, so to do that, check that out. Let me put this up here because I need more space. So let me just move this up here real quick, and then let me erase this. Okay, so we're gonna find the right and left hand limit. So limit as x approaches 2 from the left. So from the left hand side, it's gonna be function. So x minus 8 over x minus 4. That has to equal the limit as x approaches 2 from the right of 3, which is this function. So left hand limit is this, right? Because it says here that it cannot equal 2, right? So this rational function, this is a rough draft. This is not to scale, not to anything, but as x approaches 2, right? This is coming from the left hand side, I guess. So that's just a little rough draft here. Okay, so then you just plug this in, but obviously you're gonna get 0 over 0 to factor out. This is just all algebra here. So if you factor this whole thing out, right? This is sum of cubes. So if you remember the formula, it's you have a cubed. She was telling this to us in class when we did the problem where it was like p to the 2/3 or q to the 2/3. If you guys remember that, you were like, what the hell? What does she do with that formula? This is what she was talking about. So this is the formula that she was using. So if you find that something is a sum of cubes or difference of cubes like this, the formula is this. So it's a minus b times a squared plus ab plus b squared. So you can use this to figure out how to factor out this. So in this case, the a is x, right? So just like to show you here. So what's the cube root of x? That's just x. So I just put parentheses cube. What's the cube root of 8? That's just 2. So that's 2 cubes. So this is basically a, and that's b, right? So you just gotta plug that in. So if you use this is gonna be. Are you guys good? Does that?
Oh no, I'm just.
Okay.
What is this called? So I can just watch.
So this is just an experiment. This is the difference of cubes. This is just a way to factor. I mean, difference of cubes. Difference of cubes. This is a way to factor. There's difference of cubes, sum of cubes. There's also, yeah. So then you use this, you plug this in, a squared. In this case, it's x. So that's going to be x squared plus a times b. So you have 2x. This is going to be plus 2x plus the b squared. So that's going to be plus 4, right? 2 squared is 4, right? So we have this. That's gonna go above here to factor this out, right? So x minus 2 times x squared plus 2x plus 4. Although we know how to factor this out, guys, right? This is pretty straightforward. This is difference of squares, right? So difference of squares, I mean, if you want me to show you, it's a squared minus b squared. This is another way to factor. So the formula for that is just a plus b, times a minus b, right? So in this case, it's just going to be x plus 2 times x minus 2, right? So boom, boom, right? So this is just all algebra here, you see? So that cancels out, right? And then I'm going to erase all this because I need more space for, actually, no, I don't. Let me just, sorry guys, this is looking a little messy. I'm trying my best. So limit as x approaches 2. If you just already do this, this is just going to be 3, right? Limit as x approaches 2 from the right, that's just going to be 3, right? So if you plug in 2 to this is going to be 2 squared, which is 4 plus 4, 8 plus 4, 12 divided by 4, that's 3. So if you plug this in here, you're going to get 3 equals 3. That checks out.
Yeah.
Right? Mm-hmm. So remember what the continuity rules here. We found the second, right? We said that f of 2 is 3, right? So that, and then we found the right left hand limits. They equal each other and they exist. So that's 3 equals 3, which is great. And then these two numbers have to equal each other. So that's what the third step is telling you. So if you check this out, 3 equals 3, right? So this is continuous at x equals 2.
I got a question.
Yeah.
What about the third one that said like x equals -2 equals, then it will be 4?
Oh, okay. So you want to find out if at x equals -2, it'll be continuous?
I'm saying like, how come you didn't include that at the beginning, the x?
Oh yeah. So you basically just do this whole process again. So if you want to find out if this is continuous at x equals -2, then you just again. Oh, okay. I see what you're saying. So in this case, if you plug in -2, there's no number here, right? And then so I guess it's not continuous at x equals -2. So if you plugged it into the calculator, I'm gonna do that real quick just to check.
Like, I'm not sure if it's like a typo in the actual textbook. I'm saying because like at the top it says x does not equal -2,
Because it says,
blah blah blah. Then at the bottom it says x equals -2. It will be 4.
you know how to get that.
Oh wait, are you looking at the answer key?
No, I'm looking at the question, like question number 30.
Yeah. So you're talking about So like in the top function, it's x is not equal to 2, and then x is not equal to -2. Yeah.
I'm talking about the one under. Okay, you see how it says like 3 comma x equals 2?
Oh.
That's what I was asking about
my
earlier, but I
God.
thought you.
Oh
I didn't read
yeah.
it
Oh
for
my God,
myself.
guys, sorry. Okay, I forgot to include this. Okay, but yeah, so it's 4. So if you plug in 4 here, if you plug in 4 here, right? Get 4 squares, that's 16 plus 8, so that's 24 plus 4, 28. 28 over 6. Hold on a second. Sorry, it's -2. I was plugging in +2. Okay, so this is gonna be
I would be totally putting that
4
like
plus 4.
there.
That's 4 over 2. So that's gonna be 2. Yeah, so I don't think it's gonna be continuous at x equals -2 because I just plugged it in like here. Because you would just do the same thing. You would just have to put -2 from the left, -2 from the right, right? So instead, this would have to be 4, right? Because as x approach, they can't see the textbook, right?
Yeah.
Hold on a second. Let me write this all out. But we do know it's continuous at x equals 3. So that's x equals 3. Oh, sorry, I lied. X equals 2. Sorry, guys. I keep mixing this up. So we know it's continuous at x equals 2. That's good. So let's just check -2. Thank you for mentioning that, Albina. Let me go to the next thing here. Okay. All right. So
I think
if
so.
you look at the textbook, if you follow along with the textbook, you'll see what I'm doing. So if you do limit as x approaches -2 from the left, so you use the same function. So x cubed minus 8 over x squared minus 4. And then you just have to see if that equals a limit as x approaches -2 from the right of 4, right? That's what you were mentioning before, right?
Yeah.
Yeah, so that's gonna be 4, and you have to check to make sure if this is correct. So if you just factor all this out, you could just plug it in here, right? So you have -2 squared. So that's gonna be 4 plus 2 times -2, so -4 plus 4. So that's going to be 4 over 6. So I believe this is going to be 2/3, right? Let me check.
Yeah, it's. Oh yeah, there's a pretty good chance of
2 times -2 plus 4. Yeah, so that's 4.
Yeah, I'm gonna have to charge mine.
Did you do this one? Hold on a second. Let's see. Square plus 2 times -2 plus 4. That's 4.
Yeah,
and then I think this is going to be
like,
undefined on this side. So I'm just checking here. I think this is going to be undefined, so that doesn't equal that. So I think it's not continuous at x equals 4, but yeah. Let me just real quick, guys. Okay, so we are looking at 3 and 4. We know at x equals it's continuous. We just need to see if at -2 it's continuous.
Those are the two parts of the problem.
Yeah. So I checked, so that's good to go. I believe at -2 it's not continuous because I checked it and with the right and left tail limit and they don't equal each other. So that's not continuous. So not continuous at x equals -2. So yeah.
It's continuous.
And if you graph it in your graphing calculator, so what you do is you go to, if you want to check with your graphing calculator virtual, you go to y equals on your TI-84, and then you just go to y1, and then you just go to alpha y equals to get the fraction bar, and then you just put in the function. So the function was x cubed minus 8 over x squared minus 4. Yeah.
Yeah, that's what I do.
Alpha y equals will give you the fraction bar, and then you can just plug in the other stuff there.
Cute.
Yeah.
I love it.
Yeah.
Real quick,
Yeah.
wait, does this test book have an answer key?
Love that.
Does will the test have an answer key?
No, like, does this test book have one?
Yeah, the back.
Oh.
It's like to the odd numbered.
Oh yeah, like the questions here on the textbook. Yeah, there's a for the odd number ones, but like I think we're doing some even ones. So make sure that you do look at the recording again if you missed something. So yeah, I'm sorry if it looks a little messy. I'm trying my best because I'm using a mouse. So yeah.
That's all right.
All right. Let's see. What else do you guys want to cover? Do you guys want to do like an intermediate value theorem or yeah? Okay, so where's that? Like on maybe
Maybe it was it in 2.4.
was it 2.4? Let's check. I remember that it was all the way at the end,
It was. I think
right?
it was.
And it's so annoying because once you go to the book, like it immediately scrolls you back up for some reason, which is annoying AF.
So I'm glad it's not just mine.
Yeah, I don't know. They need to fix that in the program. Oh, birds. Hello, birds. Good. Oh, this is epsilon delta definition. Oh my god, I remember I did this.
I've never seen that before.
Yeah, that proves the limit definition. That's what it's about. But like, you don't really need to know that. That's just extra stuff. I mean,
I'm good. Yeah.
like, I'm good for now. Okay, I don't think it's here. Where could that be? Maybe it's in the Unity. Hold on a second, guys. I'm
There it
just.
is.
Oh, okay. And I'll just scroll down and the problem. Just looking for a problem for IBT. Hang on a second.
Yeah, that's the other thing up there.
Because they got the part that is under construction, like the one part that is.
Oh, here it is. It's this. Yeah. Let's do 77.
That works.
Right?
Oh, that's
That
2.5.
that looks pretty fun. Okay, so
Yeah.
section 2.5. Oh god. Oh. Very okay. Section 2.5, number 77. We are looking at root x plus root 1 plus x equals 4. Okay, so this is the IVT. So basically with the IVT, you're just trying to determine if there is a root and a function. So honestly, it's unnecessary, but like you have to do it. You have to see if like if this function actually has a solution. It's so to do that, like I'll just give you an example here. So let's say you have some function, okay? And you can clearly see there are two solutions here, right? But what the IVT is trying to tell you is that you want to basically like choose x values. So let's say this is, I don't know, 2 and this is like 4. So if you choose 2 x values and you get like some y value, right? You should get some c value in the middle, right? So like in this case, it'll be 3, right? So you have the output there. So that range will tell you if there's some solution. So basically, you'll usually get a negative number and a positive number. So if you get like, if your y value is negative and then positive, obviously in the graph, if you go from negative to positive, you'll have some solution here, right? Or if you're going from positive to negative, let's see. So yeah, same thing. So going positive to negative, right? You're gonna have some type of solution there. So that's what the IVT is just trying to tell you. So Basically what she said is you have to guess, you have to like choose two random numbers and see if it works out. So I guess we'll just choose, what number do you want? 0 and 3 or something? All right, so let's just choose numbers at x equals 0 and x equals 3. So we'll plug that in, right? So this is gonna be root 3 plus root 4 equals 4. Actually, let me move some stuff around here with the algebra. I wanna set this equal to 0. So let me just move me. Oh god, because that's like an algebraic thing. So I just subtracted the 4 here so that this is our function basically. All right. Okay. So we're gonna plug in 3 first. We have 3 plus root 4 minus 4 equals 0. So if you plug this into the calculator, I'm just gonna round it up with the decimals. So we have root 3 plus root 4 minus 4. So you get like around negative 0.2679 at x equals 3. So at x equals 3, it's negative 0.2679. All right, so that's good. So we're starting off with a negative number. So all we need is a positive number. And that will tell us that we'll have some type of solution there. All right, so if we do that here, right, we have root at x equals 0. So now we're plugging in 0. This is going to be root 1. Oh, God, I'm so sorry, guys. Root 1 minus 4 equals 0. This is just going to be 0. Root 1 minus 4, just plug this into the calculator. So root 1 minus 4. So you get negative 3. So you get 0, negative 3. Now, we have two negative numbers, and probably this range is not going to be good because if we were to graph, if we were to just visualize this, right? If we were to visualize this, we have, let's say this is at 3. So 0, negative 3, that's negative 3. That's like here. And then we have 3, negative 0 point something. That's here. So like if you imagine like they're going to connect somehow. So you see that there's not really a solution crossing here, right? So we probably have to choose maybe a larger range, right? So maybe we could do like, I don't know, like 1 to 5. Maybe there should be something to cross around here to prove it. So maybe we can try again and see if maybe there's a solution. So maybe let's try again. So I'm gonna erase all this so that I can have a little more space. We tried x equals 0 to x equals 3. How are you guys doing? Are you guys like, yeah? Okay. Let me know if you guys need a break or anything because this is definitely a lot. So just wanna make sure you guys are doing good. How are you guys doing virtually? Are you guys doing good?
Yeah.
Yeah, it's going good.
Okay. All right. So now let's try in between 1 and 4. Let's try that. So if we do root 1 plus, so I'm plugging in x equals 1 first. So 1 plus, can you read this? Sorry guys, this is x, so 1 plus 4. Oh, remember that you have to subtract the 4 here, so minus 4 equals 0. I just moved this here. So this is 1 plus root 5 minus 4, right? Plug this into a calculator. 1 plus root 5 minus 4. So this is going to get you negative 0.764. All right, so at x equals 1, we get negative 0.764, right? So now we will plug in 4. Let me erase this so I can have more space. It's positive finally, hopefully. All right, so if we plug in 4, yeah, okay. So we get 2 plus root 5 minus 4 equals 0. So 2 plus root 5 minus 4. All right, perfect. So now this is going to be 0.23. So at x equals 4, it's at 0.236. Okay, so now we're going to negative to positive from the y value. So that tells you that. So if we imagine it here, let's say this is 1, 2, 3, 4. This is 1, 4. So 1 is at negative 0 point something. So like let's say this is negative 1, so 0 point something. That's probably going to be around there. And 4, it's at positive 0 point. Remember, so this is 1, so this is 0.2 something. So it's gonna be around there. So if we connect it, there's gonna be some solution there. So hold on a second, guys. Let me just let this. All right. You guys hear me?
Yeah, I can
Yeah,
hear you.
yeah, we can hear you.
All right, perfect. Just want to make sure because the plane just fly by. So okay. So now that we tried again, now we have a negative to positive, right, for the y value. So this tells us the IVT. This tells us that we prove that this function has some type of has like a solution. So it says in the textbook that if you once you prove that each equation has a solution, then you can use the graphing calculator or computer grapher to solve the equation. So okay, so on the TI-84, so if you have a TI-84 or any Texas Instrument calculator, first if you want to graph how to graph functions. So you go first step, so you go to y equals in the calculator, and then you just press alpha. You just put in your function, right? Put in your function, and then just press graph, and then you should see the graph. You should see it. See graph once you put it in there. So if you follow these steps, I'll go ahead and do that real quick. So we got root x plus 1 plus x minus 4. Graph it. Hold on a second. So, oh, of course. So we have all right. So if you graph it, notice that there's a solution. So all you have to do to find that solution is you go to second calc to find solution on the graphing calculator. To find solution on graph calc, go to second trace, and then once you hit second trace, you just scroll to scroll to 2 where it says 0. Click the 0 and you should see like left right bound. So then you just have to choose like your range. You just press the left bound, press enter, right bound, enter, and it should give you a solution. If your window is too small, just go to window and you can adjust the x min, x max, y min, y max in the window.
So what do you put as your range?
I'm gonna do -10 to 10 for the min and the max. Okay, and then you just follow the same steps again. So, all right, so I'm gonna go to second trace again. I'm just checking to see the solution. Press 0, and then you press so you see how it says left bound. So go to the left side of the. So I'm gonna show you. So you see, you just have to choose left bound. So press enter, and then you just scroll up. You see the solutions there, right? So you have to like choose a little range, give it space, scroll up there. So it's gonna find the 0 right there. Press enter, and boom, it tells you that the solution's at 3.515625. So
MSC might be better.
x
So I'm gonna
equals
have to watch the video.
3.5152.
Oh, I know.
5265. Yeah. Or sorry,
Oh,
56. Ignore that. The solution of this is that if you plug this into your calculator, it's at x equals 3.515625. That's the solution. So we use the IVT to do our range. That proves that. And then we use it for the calculator. This is like little steps. Sorry, it's not really neat, but I try my best. So.
Yeah, the connection was bad. For the formula, what did you plug in for y equals?
In the calculator,
Yeah.
so you can just plug in the function. So plug in root x plus root 1 plus x minus 4.
Oh, -4. All right.
Yeah, minus 4 because we want to make this equal to 0. So yeah, this. Want to make sure that this is always equal to 0, the function. So you might have to do a little algebra there. You plug that in, and then you go to second trace, 0. So 2:0. Then you have your left and right bounds. Press enter for the left, like to the left of the solution. Press enter to the right of the solution. Press enter again, and press enter, and it should give you this.
where did you move from? Oh, yeah, that's far.
Oh, nice.
Far enough.
I got into VMI. I really wanted to go, but yeah, we just couldn't afford it. Too expensive. Yeah. How are you guys doing virtually?
All right.
Good.
Stuff like I applied for one when I was a senior, and I my local school. I got.
Oh, nice. How was your gym? It was good. Is it like the same vibe as like here? Like,
I don't really know the vibe yet. This is my first semester here, and like, it's this.
oh, cool.
And I'm
Okay.
kind of like introverted, so I didn't do much at UGA anyway. So
Oh.
there's no point in watching
Yeah.
TV, you know.
Yeah.
But the food was good. Food was better.
Oh, great. Oh, really?
Yeah, like it's like the Athens food was better than South food. Well, I mean, we have the same stuff. We have Canada. We have like pizza place for the Einstein Rose.
Can we have this use number solver? Like, would that have work to find the x?
Oh, okay. So you go to. So are you at y equals? Where are you at? Are you in graph?
Yeah, like I did like the graph and like I did what you did like and it showed. I'm saying like number solver.
If you want, I can FaceTime you later and I can show you because it's a little complicated to explain. You could just you're in the group chat, right, for calc?
Yeah.
Yeah, so just DM me and then I'll show it to you, and video is easier because it's a little complicated to explain it. And we have to move on to the next problem. So
Yeah, that's all right.
all right, yeah, okay. All right, Albina. I won't forget that, okay? just making sure. All right, what other problems you guys want to go over? What's like something that really
I feel like the most stuff was the stuff I was like having the hardest time, and I get it now.
yeah.
Really, I was like, yeah, I'm good. Like I can do most of the.
Limits constant.
Yeah.
Okay. If
Yeah.
not, we can do more. You guys want to do more chapter 3 practice? Maybe.
I'm down if y'all can. I don't.
I think we can fit in another problem real
Yeah.
quick. Just like
Yeah.
just find a okay. Okay. That's a way to. Sorry. No.
Math is fun.
Let's do maybe. All right, hold on a second, guys. Look here. Let's do. Have we done this one? X squared minus 2x.
I don't.
Straightforward
X squared
problem.
minus 6. You could do that.
Okay, let's. All right, so let's do. So let's do f of x equals x squared minus 2x. So let's find the derivative of this function, just the function itself first. So again, we have to use the limit as h approaches 0 of f of x plus h. So anytime you see an x, you just put plus h. So this is going to be x plus h squared minus 2 times x plus h, right? This is just how I think of it. So using this way, whenever you see an x, just put a plus h, and then just minus bracket function itself, which is just x squared minus 2x, right? Keep it all organized. All over h. Boom. And you just got to simplify all this. Just simplify it. So again, I can do this mentally. For those who took calc, you could also do this mentally. If you one deciding like, okay, what's x plus h squared, like h and everything here, and solve it out. But to simplify x plus h squared, it's going to be x squared plus 2x8 plus h squared, right? And then simplify this, right? Minus 2x minus 2h, pretty straightforward, right? And then minus,
That's 2xh.
yeah, minus 2x minus 2h, because you're spoiling this out, right? And then minus, so you distribute the negative, right? So minus x squared plus 2x, right? All over h. And then this might look scary, but you don't gotta worry about it because you just have to cancel stuff out. So this is like the satisfying part because you're like, oh, x squared minus x squared, and you have minus 2x plus 2x, that cancels. So you basically you should have 2x h plus h squared minus 2h over h left. So then you just gotta bring everything down, right? So you have 2xh plus h squared minus 2h all over h, right? And then from here, just algebra, you just gotta factor, right, on the top. So you continue. You take out an h, right? So h times what? So you got 2x and plus h and minus 2 all over h, right? How you guys doing? Virtual.
Oh,
Oh, yeah.
Good.
Good? Guys here. Okay. All right, so then you just cancel the h's out, right? I'm gonna move over here. Limit h approaches 0. And then you have 2x plus h minus 2. And then you plug in 0 to h. That's just 0. And you have 2x minus 2. So that's the derivative of the function itself. I mean, if you use the differentiation rule, the power rule, this would be just 2x minus 2, right? Yeah. Shad is over here. He's like, yeah, that's all what you got to do. So, yeah, so that's that. And let's say we wanted to find it at a point. So let's say we wanted to find it at f prime of 1. So we know f prime of x, right? This is the derivative of this function, which we just found doing all this, right? We know the derivative of the function is 2x minus 2, which is what we just did. So to find the point, you just put your x value in, f prime of 1, right? 2 times 1, oh god, sorry, minus 2. So that's going to be 2 minus 2, 0. So at f prime of 1, it equals 0. And if you were to, yeah,
If we have
yeah.
now.
And then if you were to graph this, well, actually, yeah, so if you were to graph this on your calculator, or I can also show you guys here. So we have x squared minus 2x. Let me just go ahead and see. I know what it looks like, but I just want to, I'm going to squared minus 2x. Okay, so we're going to basically have a quadratic function, and it's going to look something like this, right? This is f of x equals x squared minus 2x. So basically for this, we want to, remember how we said we want to find the derivative of x equals 1? So if we go to 1, let's say, okay, this is 1. Hold on. Let me move this one up. Oh god. Sorry guys, hold on. So at x equals 1, you notice how if you take the slope of this line, it's horizontal. So the slope of a horizontal line is 0, which is what we got here when we plugged it in, right? So that's another way we can check that to make sure it's correct. So yeah.
We're good.
Oh yeah, and then also to find the point slope form, so we know m equals m equals 0, right? X equals 1. Plug in 1 to the function here. So this is going to be 1 minus 2, so that's going to be negative 1, right? So we do y plus 1, y minus 1, y minus negative 1 is plus 1 equals m, which is 0, times x minus x1, which is just 1. And then you have y equals, this is just going to be 0. And then you take the negative 1 here, it's going to be minus 1. So that's going to be negative 1. So I guess that's the point slope form, or
why? I don't know. I just know
yeah,
because
because the thing is, this is y equals negative 1, so I guess this is like the what is it? The
slope intercept. Is that?
not slope intercept.
Yeah, that's
So 1 negative 1, yeah, because it may bring out over here again. So basically that, I guess that's the point slope form at y equals negative 1. So. All right.
Her handwriting with the mouse is faster than mine. No, you're fine. I was just
No,
confused
it's
'cause I was
okay. Yeah,
looking at
I'm
it and I was
just
like,
yeah.
why does this not look right? And then I realized it's just I wrote down something. 'Cause you wrote it down right.
Yeah, that happened to me the other day. Like I wrote like 2 and it was supposed to be a 7 and I was like, where did the 2 come from? Like I was sitting there, I was like staring at it and I was like, and then like my 4s sometimes with like 9s. So it's like I don't even know what I'm saying. I need to start writing my 4 like that so that like one day I'll learn.
This helps. This calc. If you want to pass it around, check it out. This is the properties and stuff. So pass it around, check it out. Yeah, I'm just showing the face-to-face people just some of my old calc notes. You know, I can also send it in the group chat as well.
Yeah, can you like
So,
take pictures of these?
For
and-
sure, yeah, I'll definitely do that. So
them?
I have some old calc notes. I'll definitely show it to you guys. I think that's it for this session. I hope it helped you guys a little bit. Get an idea on what the
There's, like, the
content
IDs and stuff
will be
on
like on the
there, so there's,
test.
like, some of them.
I'm sorry if my handwriting was a little bit messy. I tried my best because you know I'm using a mouse and I haven't used a mouse in a while. So hopefully that helps.
This was so helpful.
But thank you so much, guys, for attending. For those of you who couldn't attend, don't worry. You can just watch the recording. And yeah, thank you so much, guys. That's it.
Appreciate it.
That was helpful. Thank you so much.
Yeah, no problem. All right, see you.
You killed
Bye.
it.